Okay, integration. There is about 3 to 4 weeks of prep work for integration that you should do and not ignore, okay, in your calculus class. It's very important. You should definitely understand it. But I need you to get through what we need to get through here for the rest of the semester. Integration, okay, very simply, like I was saying before, is finding an area. Okay. Now, all I'm going to do is show you how to take a few basic integrals so that you can answer some of these questions. But understand, all you're doing is finding an area. Okay. If you have, okay, something like this. Again, we kind of went over this, and I'm going to use a specific concept to develop it. We said that work was equal to the integral of f dot dx. Forget about the dot product part. We're just going to look at it one-dimensionally. So we'll just say f of x dx from an initial state to a final state. Okay. And let's just say you have something that looks like this. Okay. We said that it had to do with the area under the curve. And if we make our initial state all the way back to 0, right, it would be the area under that curve. We start off with x to 0 to x final. Now, looks like half of a whale, or if it can whale, something like that. All right, so now, we want to find the area here. Well, that's kind of complicated to do. We need a function for what it is. Okay? But what we do is find the area of very tiny little slivers. So I take a sliver like this. This part right here is called a delta x. Okay? If I squeeze it infinitesimally small, okay, that delta x, which delta means it's a discrete function, we squeeze that down so far so that it's infinitesimally small, and we make that dx. Okay? So now, the area of this is going to be the width of it times, we say, about the average height. Well, this is your f of x, whatever function you're dealing with, whether it's force or electric field or what have you. Okay, your f of x, your function as of x here. I probably shouldn't use f of x. I'll just make it force as a function of x. I'll be specific again. Okay, this is the height. Dx is your width. Now, if I want the whole thing, I have to add all those up. So that's where this writing comes from. F of x, that's the height. Dx, that's the width. This thing here, okay, that is an integral symbol. Okay. This means, this is just what it is, where this comes from. It means S for sum. We're going to sum up all of these little dx's, okay, infinitesimally slim dx's. Okay. The I means that that's the initial state, F is the final state. Just like when we did delta something, we always look at the final minus the initial. Okay? Final state minus the initial state. Well, we're going to do that here as well. Okay? So specifically, we're going to say x initial minus and x final. Okay, x final, whatever the x final value is, or the value at x final, minus whatever the value of f is at x initial. So now, so that's how we are going to use integrals when we're dealing with work. Now, as for the function that you put in there. Okay? Think about what you do when you take a derivative. If your function is ax to the n, your derivative, I'll say that this is your y. Your dy dx would equal n. Okay, you take the function here, it's n times a to the times x to the n minus 1. Okay? So now we want to reverse that for an integral. Integral y, which is a function of x. Now it always has to have a dx. Where am I? You always have to have the width. Okay, putting it in more mathematical terms. So here I multiplied by n to get to here. So I take this and I multiply it, right? So now I'm going to need to go to a one higher power. So first of all, instead of x to the n going to x to the n minus 1, I know I'm going to have x to the n plus 1. Here I took the value that I had, multiplied it here. Well, to do it backwards, okay, the a is unaffected. I have 1 over n plus 1. Okay? Think about it. If I took the derivative of this, x to the n plus 1, well, I multiply this by n plus 1. That goes away, it's 1. A to the x, 1 less than this would be n. Ax to the n, which is what I want to have. Okay? This is the it's called the antiderivative, doing it this way. Okay? It's what's called an antiderivative or an indefinite integral, because I haven't put values in here and here. I just want you to learn this part of it first. Okay? So as an example, let's just say that we have 6x to the 4th. Well, if I took the derivative, multiply this by 4, I get 24. X to the 1 less power is 3. If I take the integral of 6x to the 4th dx, by the way, you always put in the dx, this 4, okay, it's to the 1 higher power, so it's 5, and I do, okay, the a is 6, 1 over n plus 1, that's 5, so I have 6/5 x to the n plus 1, so that's 4 plus 1, which would be 5. Think about it. You can check your work. Take the derivative. I have 6x to the 4th. That's what I get. Take the integral of this. Get this back out. So if I do it backwards, 1/4 would be 24 over 4, which would be 6. X to the 1 higher power, 4. Boom. That checks out. Okay. Cosine of x. If I take the derivative of cosine of x, let me do it this way. A cosine of bx. Okay, this is a chain rule thing to take the derivative. So this would be a sine, and it's still the same function, bx. Okay? The derivative of cosine is a negative sign, though. Negative sign. I'm not going to go through proofs on this. Okay? Now, here's the thing. Derivative of sine is cosine. Derivative of cosine is sine. So now, I'm still going to get a sign out here. But instead of b times a, okay, I'm going to have a over b. It's still going to be negative. this one will be positive. A over B sine of bx. Okay. You have to take the derivative of what's inside here, so that's b. That leaves you with a. Take the derivative of sine, get cosine. A cosine bx checks out. So let's just say I have 5 cosine of 3x. All right, and actually I should probably, I'm not going to separate this. This is just our specific compared to the general. So now, I want the derivative, okay? It's going to be b times a, so I get negative 15 sine of the same argument, 3x. Similarly, okay, it's positive 5/3 sine, still 3x. A sine bx. Okay. Derivative of sine is cosine, so this would be ba cosine bx. This is positive. Okay. Derivative of sine is cosine, derivative of cosine is negative sine. So if I want to get this, I have to have a negative for derivative. This will be a over b cosine of bx. Take the derivative of that, b comes out, you get negative a. Okay, take the derivative of cosine, you get negative sine. So you get the sine of bx, negative, negative, positive, positive, and we're back out to where you would expect. So if I have 4 sine of 2x, take the derivative, I get positive 8 cosine 2x. If I do this, I get negative 4 over 2, which would be negative 2 cosine bx, which would be 2x. Final one I want to do is e to the x, just in case you see it. So let's just say that I have a e to the bx. Derivative of e to the x is e to the x. It's crazy, I know. It's a derivative of itself. So the integral of e to the x is, guess what? E to the x. Because derivative of stuff, blah, 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 same thing. I take the derivative, okay, of a e to the bx. Well, now I do have this argument in front of the x, so it's, I have to take the derivative of this and multiply by that. So I get ab e to the bx. And if I do it over here, I get, if I want to do the integral, it's a over b e to the bx. Take the derivative of that, I get the b comes out, multiplies by a over b, a e to the bx, which is what I had in the first place. So 5 e to the 3x. This would be 15 e to the 3x. 5 over 3 e to the 3x. So now, how do I use these fancy little things right here? Okay, that's a definite interval. And by the way, I'm basically blowing through about 2 to 3 weeks of calculus class doing this, skipping over a whole bunch of other things that you guys should know, like proofs of how these things come out. Also, like I said, I'm cutting out 3 to 4 weeks of prep work that you really should have. I just want to give you guys a basic understanding of how this stuff works. But you definitely need to know how a definite integral works. So let's just say that we have y is equal to, make it a force. F of x, the force here is equal to 5x, we can work out a little bit more nicely. 8x cubed, okay? And this is going to occur from my initial position of 2 to my final position of 5. All right, so now, the work that occurs between here and here, the work that occurs equal the integral from x equals 2 to x equals 5. That's where they go. 8x cubed, and we have a dx over here. So now, I take the integral of this. We don't worry about this 2 and 5 first. So the work that I get here, 8x cubed dx, this is just telling us what we're integrating over, which is x. Remember, it is the width of what we're dealing with. This is, so now, think about what I had over there, okay? It's, your a is 8, your 1 over n plus 1, so this will be 4, so 8 over 4, so this is 8 over 4, x to the 1 higher power, which is the 4th, and now, here's where we introduce 2 and 5. You might see it as just a straight line. My calculus teacher did it like this. Ms. G might do it differently. Mr. Decker might do it differently. This is 2x to the 4th from 2 to 5. Now, remember, we're looking at a final state minus initial state. So whenever we're doing this, remember, it's always going to be final minus initial. We start off at 2, we end at 5. Guess what? If we did it backwards, we'd have to subtract, we'd get a negative out of this. So now, what I do, I plug in the higher value, I do final minus initial. That's a key, final minus initial. So I plug in the final. So the work here is going to equal, I plug in the final value, which is the 5. Okay, 2 times 5 to the 4th minus 2 times 2 to the 4th. That's going to be the work. That's how I do a definite integral. Okay? 5 times 5 to the 4th is 25 times 25, which is 625. So 1250. Yeah, 625. Minus, this is really 2 to the 5th, the whole thing. So 2, 4, 8, 16, 32, minus 32. So the work done in this case is equal to 1218 joules. Yes, I dropped units, but usually, well, yeah, I would have to put units in on this. Really, you should find out what units of 8 are. Come into class. Tell me what the units should be for this. Your A is 8 in this case. Tell me what the units are. That's your homework, in addition to your other homework. All right. That's calculus in a very, very small nutshell. Okay, that's integral calculus in a very, very small nutshell. There is so much more to this, but I got to be able to get you through some of the basics on work with a variable force. So I will see you on Tuesday.